2, so make sure you have your notebooks out. We're going to take some notes. We're going to learn some new properties. We're going to build on the skills that you guys learned in Chapter 1 that we just did the test for. So remember from Chapter 1, some of the things that are really important to remember for this chapter is the substitution principle. So anytime you have two values that are the same, like 2 plus 2 and 4, you can substitute one for the other. So anytime you see, for the rest of your careers in math, a 4, you can write 2 plus 2. Or, if you see 2 plus 2, you can substitute 4. Either one, as long as they have the same values. Grouping symbols are going to be used to organize our order of operations. So we have to do things inside the grouping symbols first. So whether they're parentheses or brackets or braces, that's what we're going to do first. The absolute value of a function, or of any item that you have, is going to be positive. So if you have the absolute value of A, it's just going to be A. And if you have the absolute value, or the opposite of A, it's going to still be A. And then finally, for the opposites, negative A, or the opposite of A is just negative A. And the opposite of negative A is A. So when we do the opposite, we just flip back. Sure. Eric, can I hold that? You had those from Chapter 1, right? Okay, so today we're going to learn 6 new properties that are going to be super important for math. So today we're going to start the properties that you're going to use for the rest of this year, and then you're going to use them again next year in geometry, and then you're going to use them 2 years from now in Algebra 2, and then hopefully if you go on, then you're going to continue to use these. And these are properties which still confuse some of the older students. So hopefully today we're going to clarify what these are. You're going to learn them. You'll write them in your notebooks. You're going to go home and you're going to study these, because we'll probably have a short quiz sometime early next week just on the names of these properties so that you can identify them. And that way, by the time you get to for the rest of this year and then 10th and 11th grade and all that, you won't get those confused, because we still have some confusion with the older students. And then I'm going to show you how to use those properties as we go through them. I'm going to help you to use these properties, and we'll do it together so you can simplify some expressions, which is what the beginning of this chapter is. And then you're going to practice. I'm going to give you a worksheet for you to finish up class with, and you'll do that on your own and as I go around and help you. And then your homework assignment, by the time you get it tonight, you already have the sheet. You should be able to get at least 75% of those. Okay. So the first one is the closure properties of addition and multiplication. Closure properties just means this. If you add 2 numbers, or if you multiply 2 numbers, because that's what the sum or product is, right? The sum means you're adding 2 numbers, and the product means you're multiplying 2 numbers. So if you add 2 numbers or you multiply 2 numbers, you're going to get a real number, and it's going to be a unique number. What does unique mean?
It's its own number.
It means one and only one. Okay? So if you add 2 plus 2, what's the answer?
4.
Raise your hand. 4. Could it be something other than 4? No, because it's unique. When you multiply 2 numbers or you add 2 numbers, there's only one answer. Now, that 4 could be represented as 2 plus 2, but that's still the same number. That's just substituting a different number, right? 2 plus 2 and 4 are the same thing. Okay? So that's all that the closure property of addition or multiplication means. It means if you multiply 2 numbers together, or if you add 2 numbers together, you're going to get a real number and a unique number. Just one answer. Okay. Who knows what this picture is? Noah. A traffic jam. Those are people, and I can't tell by the sign what city they're in. I think maybe it says Kissimmee. Maybe that's Orlando. Anybody ever been to Orlando? Okay, so this might be a traffic jam in Orlando. I can't tell. But these people are commuting to work or commuting to Disney World or wherever they're going. Who's ever heard the word commute before? What does it mean?
Commute means to travel.
To travel. To move. You can have a short commute. If I walk from here to the door, I'm commuting. I've just commuted 3 feet. Some of your parents might have a long commute to work. All it means is you're moving, okay? So commuting means moving. So the commutative property of addition and multiplication means if you're adding 2 numbers or if you're multiplying 2 numbers, you can move them around. So if you're adding A plus B, that's the same thing as adding B plus A. The order doesn't matter. You can add things, 2 numbers in either order, and it's not going to change the answer. The same thing with multiplication. And you know this, right? 2 plus 3 equals 3 plus 2. They'll give you the same number. And the same thing with multiplication. 2 multiplied by 3 is the same as 3 multiplied by 2. So you can move those around on either side of the addition sign or the multiplication sign. Okay? Now normally when you have 2 letters together, we're not going to put that dot for the multiplication. I did that there so that you understand we're multiplying. Yeah.
Can you slow down a little bit?
Oh yeah, I talk a little fast. So here you are going to multiply those two things. And so I put the dot. But typically in your book, you'll see two letters together. There won't be a symbol in there. So if there's two letters together, then typically those two letters are being multiplied. That's what you're doing. So it's understood that you're multiplying. If I have a letter and a number, if I have two numbers, then I'm going to use that symbol. Because if I have a 4 and a 5 next to each other, that doesn't mean 4 multiplied by 5. It means the number 45. Okay? So understand what the dot means. So basically, though, it really doesn't matter which order you go in. You can move those around. You can commute those. You can move them. Okay? All right. If you have something like this, now we're getting to our expressions that we did from last chapter. So if I have 4 plus 5y plus 3, it means that I can move that 5y and that 3 around that plus sign. I can move them because it's addition. So, and I can move the 4 and the 5y. So notice here that I've taken my 4 and my 5y, and all I've done is move them on either side of the addition sign. And by moving those, I can now add 4 plus 3 and get 7. So my answer is... I'm getting 5y plus 7. Okay? Same thing with multiplication. Down here, all I've done is done the same thing, and notice there's more things. So I have 5, and this is multiplied by a. Again, so notice that there's not a dot because it's understood that if the number and the letter are next to each other, that you're multiplying them. So what you really have is 5 multiplied by a, multiplied by 3, multiplied by b, multiplied by 4, multiplied by c. And I can move those things around because all there is multiplication signs. So anytime I'm multiplying things together, I can move them around. So notice that I moved them around so that the numbers and the letters are next to each other. Well, I can multiply now when they're next to each other. 5 times 3 is 15, and 15 times 4 is 60. We don't know what A, B, and C are, so we just have to leave those the way they are. Okay. All right, let's see. So let's see if you guys can commute. All right. Shay. By looking at this, do you know what the answer is? Can you quickly in your head, you know, if I said 2 plus 2 in your head, you quickly know it's 4, right? Can you look at that and know exactly what that is right off the top? No. But look how easy it is if you commute, okay? So this is all about commuting. So what two numbers here could you add together that you know right away, Shay?
23 and 277.
23 and 277, okay. What other two numbers can you add together up there and you know what the answer is right away?
93 and 7.
Okay. So now, by moving those around, what's 277 plus 23?
300.
300. And what's 93 plus 7?
100.
And now what's the whole answer?
400.
Wow. Isn't it fun to commute? All right. Let's see. Nathan. Do you know what 50 times 9 times 2 times 9 is real quick in your head? Okay. So let's commute these and figure out two things that you do know. What can you multiply by 50 here that you know the answer to? 2. 2, okay. So you don't need a calculator if you know how to commute. Okay. What are the other two numbers left? 9 times 9. Well, what is 50 times 2, Nathan? 100. And what is 9 times 9?
81.
What's 81 times 100?
81,000.
What's 5 times 100?
5 times 100 is 500.
What's 10 times 100?
10 times 100 is 10,000.
Or 1000, which is 1,000, right? What's 81 times 100?
81,000.
8100. What you're going to do is anytime you multiply anything by 100, you're just going to add the 100 after what you're multiplying. So if I'm multiplying 2 times 100, that's 200. If I'm multiplying 99 times 100, it's 9900. If I multiply 81 times 100, it's 8100. Does that make sense? Good. Okay. It's so fun to commute. All right. The associative properties of addition and multiplication. Okay. When you associate, what do you think of when I use the word associate, Desiree?
Talking to other people.
Talking to other people, right? You associate with them. Very good. You see all these people here, they're associating with each other. So when you think of the associative property, that's what you want to think of. You associate yourself in groups. Okay, when you go to lunch, Felix, when you go to lunch, you can't associate with everyone at the school, right, at the same time. You couldn't have that conversation. You wouldn't be able to understand everybody if everybody was talking to you. But you have a group of people that you associate with, right? You have a few people you hang out with at lunch, right? Okay, you associate with them in a group. Okay, so that's what you want to think of. When you're thinking of associate, think of a group and interacting or being with something else. So if you're multiplying or adding three numbers, A plus B in a group, and you're adding another number to it, it's the same as taking that first thing and then adding it to the second group. So notice here, when I'm associating, I didn't move. I didn't commute these numbers. A, B, and C are still in the same order. Desiree and, I'm sorry, I forgot your name. Tiffany and Hojin. You're sitting here in this order, okay? Right now, if you're talking to Tiffany, you can associate with Tiffany, okay? But you can also turn and you can associate with Hojin. Your positions didn't change, but who you associated with changed. So with addition and multiplication, we can do that. So notice, my position didn't change, only my grouping changed. So your group can change, and the same thing with multiplication. So A multiplied by B, and that group can associate with C, and so A can also associate with B and C. So it doesn't really matter when you multiply or add the numbers. It doesn't affect the result how you group it. That's what the associative principle says. Okay? Very good. Let's show you that that works. Okay. You all love fractions, right? We have 44 2/3 plus 1/3. Well, 2/3 plus 1/3 is what? 1. Good. So 44 plus 1 is 46. Okay, that's not too bad. 6 2/3 plus 4, well, there's no fraction on that 4, so it's just 6 2/3 plus 4 is just 10 2/3. So if I add those together, it's 56 2/3. You see that, Alex? Okay. Now, what if I associate differently? Notice here I associated the first two and I associated the last two. Okay? Well, what if I do it differently? What if I associate them? What if the middle two want to associate? So I can keep my 44 2/3. What is 1/3 plus, 1 1/3 plus 6 2/3? Elise.
7.
6 plus 1 is
Oh,
8, because 6 plus 1 and then 1 because they make a whole. So it's 8, okay? So now, what if I want to associate? Now, once I get to this step, I want to associate my whole numbers because that's easier to add. You could associate them this way. It doesn't really matter. But I'm associating it this way because it's easier to add whole numbers. Eric, what's 8 plus 4? 12. And then 44 2/3 plus 12, 56. If you need to see that. 56 2/3. Notice that they're the same. Okay? So that's the idea. It doesn't really matter which way you associate them when you're multiplying or adding. Okay. I know you guys want to associate, right? Okay. 3 multiplied by 7x, and 7x is their own little group. Okay. So Kate, how would you associate? 7 times x doesn't tell me much, right? I can't, I don't know what x is, so I can't really do anything with that to simplify that, right? But if 7, what can 7 associate with that I know what to do with?
3.
3. So that's the same as 3. And I got to put the dot because the 7's there. Right? So the 3 can associate with the 7 instead. So I can just move my parentheses. Notice my 3, my 7, and my x didn't change positions. All that changed was how I'm grouping them. What is 7 times 3?
My name's Katie.
I'm sorry. Okay. And 7p multiplied by 6q. Desiree, what do we know in there that we can associate?
7 and 6.
Right. But notice that in order to get them next to each other, now I have to move them. So if I'm going to move them over the multiplication, what's that property called?
It's called commutative.
Commutative. That's what we did before. So first we have to commute. So pick one of those ones to commute. It doesn't matter which one. Pick one.
7.
7p? Okay. So that's the same as p7. We commuted. Okay. Now if we're going to associate, what two things do we have that we can associate together?
6
6 and 7. What is 7 times 6?
42.
42. Can I simplify my P and my Q? No, you gotta watch your P's and Q's. You can't mix those together. So we have to leave those by themselves, which is just PQ. And by the way, in order to move my P back over here next to the Q, what property am I using? Weston. Commutative again. Good. 42 PQ. All right. The last three properties of quality are really easy, but at the same time, the wording can confuse you. Sometimes you can get them mixed up. So it's important to know what these are. So you're going to write these down. The first one is the reflexive property of equality. And I think of this as a mirror, because whatever is on this side of the equal sign, the same thing is on the other side of the equal sign in the same order. If you look in a mirror, what do you see? You see your reflection. You see you. So if A is over here, the same thing is over here. That's all the reflexive property says. And that might seem really basic to you, because you know that 2 equals 2 and 6 equals 6. But as you go on in algebra, you're going to find problems where you're going to need to use those in steps to prove that something is algebraically true. So this is important to know. So when you hear a word reflexive property, think of a mirror. Okay. The symmetric property just means that if you have an equal sign, the symmetric property of equality says that you can move them over either side of the equal sign. Okay? So A equals B is the same as B equals A. In other words, it doesn't really matter whether it's on the right side of the equal sign or on the left side. It's the same thing. You're saying the exact same thing either way. Okay? That's the symmetric property. And then finally is the transitive property. I have some guy transitioning here over, it looks like a little bridge on the water or something we found. So what this is saying is this. If A is equal to B and B is equal to C, well then the first thing, the A, is also equal to the last thing, because they're both equal to B. So this basically says that if, let's put it in numbers because you'll understand it easier in numbers. Did you have a question, Felix? All right. So let's say 3 is equal to, what's something that 3 is equal to?
3.
Yeah, it's equal to 3 by the reflexive property. Good. What else? We're using the substitution. What can I substitute for 3? What would be the same thing? I could use a variable in a particular question. X could be 3, but X is not always 3. So what is always 3?
3.
Well, always 3 plus 2 plus 1. So 2 plus 1 is 3, right? So we know that 3 equals 2 plus 1. Okay? And then notice here we have, what is 2 plus 1 equal to? Well, we know it's equal to 3, but what else? Something else. Somebody give me something else other than 3 that 2 plus 1 is equal to.
4 minus 1. 3 is equal to 4 minus 1.
4 minus 1? Okay, yeah, those are equal. Okay, so what's that saying is that if 3 is equal to 2 plus 1, and 2 plus 1 is equal to 4 minus 1, no, sorry, I'll make that look more like a minus instead of a multiplication sign. That means that the 3 must be equal to the final thing as well. And is that true? Is 3 equal to 4 minus 1?
Yeah.
That's all the transitive property says. You're transitioning from one complete sentence to another complete sentence, and getting a third complete sentence that combines those two. Okay, so you learn that when there's an equal sign, that's a complete sentence. On one side is a statement, on both of them is a complete sentence. So that's all that the transitive property is doing. Okay. All right. All right, Tim. Since you wanted to tell me here, name that property. It's not name that tune, it's name that property. So of the 3 that we just went over, what's this first one? 3,456,701 is equal to 3,456,701.
Reflexive.
Reflexive, very good. Oh, look at magic happen. All right, let's see. Who wants to do this one here? 21 is equal to 11 plus 10. 11 plus 10 is equal to 20 plus 1. So therefore, 21 must equal 20 plus 1. Alex?
Yes.
What's the name of the property? Which one of those properties we just went over is that?
Transition.
Transitive, right. Notice that A equals B, 11 plus 10 is just a b. Notice the same b is equal to, that's where the magic breaks down, huh? Is c, so therefore a equals c, okay? That's all that is. You're putting numbers in for it.
It's smart.
Yeah. And what did we call that again? Transitive. Okay. And then the last one, oh, I'm sorry, I sort of wrote over that a little bit, didn't I? Hopefully you can read that. 60 equals 6 times 10. So 6 times 10 equals 60. So we just flip those on either side of the equal sign. What do we call that? Noah? Symmetric. We're still getting used to this.